Greetings, chemistry students. Today we're going to look at how we can determine whether a single or double replacement reaction is going to actually happen. So for single replacement reactions, an element that is higher on the activity series will replace an element that's lower on the activity series. So to do that, we need to look at our reference tables, and on page 7 of our reference tables, you'll find this activity series. And there's actually two activity series. There's an activity series of halogens, and then there is an activity series for metals plus hydrogen. And essentially this works as kind of a hot or not list for the elements, where the most attractive elements are at the top of the list and the least attractive elements are at the bottom. And so I'll kind of give you an example here. If we look at this first example here, magnesium plus hydrogen chloride. Well, magnesium is by itself and hydrogen is paired up with chlorine. So we need to find magnesium on this list. It's right here. And then we find the other thing that's on the same list. We don't look at chlorine. That's a separate list for halogens. So we're going to find hydrogen. Magnesium is higher than hydrogen on the list, so chlorine, that's currently in a very long-term one-day relationship with hydrogen, sees magnesium and it says, I think I'm going to break up with the hydrogen and hook up with magnesium. So instead, we're going to have magnesium replacing the hydrogen, giving us magnesium chloride. And if you remember, magnesium has a +2 charge and chlorine's a -1, so it's MgCl2. And then we're going to get hydrogen left all by itself. And hydrogen is one of the diatomic elements. Those are nitrogen, oxygen, chlorine, bromine, iodine, fluorine, and hydrogen. And the way you can remember those is you start with element 7, which is nitrogen, oxygen, fluorine, chlorine, bromine, iodine. It kind of makes the number 7 right there, plus hydrogen. So I call them the deadly 7, because they can be deadly to you if you forget about them. So that's how this activity series works. And this would be a single replacement reaction here. If we look at the second example, we have copper and hydrogen chloride. Well, copper is down here, hydrogen is above it. Since copper, the thing that's by itself, is lower on the list, there is no reaction. In this third one, we have zinc is by itself, so we find zinc, and then copper is the metal that's in the compound, which is down there. The thing that's by itself is higher on the list, so we do get a reaction. We're going to make zinc sulfate and copper. In this fourth one, here the thing by itself is a halogen. So look at the activity series of the halogens. I find that bromine is lower on the list than chlorine, the other halogen. Ignore the potassium, it's on a different list. So we get no reaction. And then we compare chlorine and zinc iodide. Chlorine is higher on the list than iodine is, so we do get a reaction, and we make zinc chloride plus iodine. So that's single replacement reactions.